against individual targets as if we thought that single target would cause of disease, that bet was a wrong bet. So we're entering a phase of the dark ages, of the dark side of the pharmaceutical industry, where they'll have to get into other forms of businesses. And the most important thing is here, in terms of my message to everyone here today, is that population data is not well suited for the individual. And that's why the debate over what nutritional plan is an anti-cancer plan will never be able to be answered, because the answer is it depends on the individual. We've thought about these things, metabolic profiling. You can hear some intelligence on that. You've heard about ABO diets because it's trying to get into an individual archetype, but it isn't as sophisticated as it will need to be in order to deal with us as an individual. And a good part of my lecture today deals with that. So the concept of layering multiple disciplines came to me, and that was the hypothesis that I formed Anatara medicine under. And that was the experiment that I wanted to gain much more experience with, because I understood that for me and my family, this was the way to go, and that was the bet I was willing to take and make. As long as it was done safely, as long as it took into account these different patterns that are listed here, and also take into the account of what Bert said. We have to take the emotional realm into account, we have to take the energetic realm into account, we have to take the electrical realm into account. We have to take all these into account because they're real, and we might as well not avoid it, certainly not in this community. But my fellow professors at UCSF aren't quite open, but they will need to open their minds to these things in the future. So we have tremendous technology, and the technology is real. There's no reason in the world not to use it, except in this case where the radiation exposure is tremendous. But the technology is, when you think about it, the technology is almost solely observational. It isn't physiologically based. In this case, yes, you'll see which parts of your system is utilizing glucose at a faster rate, so you can pick up tumors more likely, more accurately, or inflammatory foci more accurately. But it's still observational. And then you have the emergence of the last 2 decades of MRI technology. Again, it's observational. Now, when you read an MRI of someone's knee, it takes about 2 pages. The radiographic report, radiology report of your knee anatomy, it takes about 2 pages to read, because every single fiber of every single ligament is exposed. The question is, how do you avoid that level of degeneration? How do you avoid having furthering of the osteoarthritic component of the knee? It's something as trivial as, relatively trivial as a joint versus the entire system is made more complicated by the observations, but the question is, what is the benefit of the extra observational power that we have? We can mine the data better, but the question is, what are we going to do with all this information? So, the concept of CT scans and I just sort of smile every time I think about it. I was probably 26 years old, and having the chief of surgery of Albert Einstein Hospital come down and explain to me that he didn't understand how to read the CT scan, which was cross-sectional here, because he actually practiced the majority of his abdominal surgery through a very small incision. And it never occurred to me that surgeons do practice that way. They don't open everything up. So we were at the point of knowing so much, but actually not having real experience in the human body, although we have tremendous experience in the digital manifestations of the human body. So it's the data that's coming from us we're observing, but we have little knowledge of how to integrate it. So what do we have? We have the pharmaceutical industry, and we have the reason I showed this, and we all have our biases, and some of us use pharmaceuticals more than others. Some of us are very against it. I've been a chief medical officer of a nonprofit pharmaceutical company, I understand how to develop medicines. I understand about the FDA. I understand the good, the bad, and the ugly. But I put this on to really show the concept of when you take individual medicines based on individual receptors, you're going to have to take a lot of medicines. For diabetes, there are 12 known molecular pathways today, and some 50 or 60 diabetic medicines. There are 3 or 4 new pathways under active investigation now, so there'll be 16 different molecular pathways to attack, quote unquote, a type 2 diabetic. So why doesn't one drug work? Well, because one drug is based on a single receptor, and this is a multi-gene expression, multi-receptor based disorder. So you'll need to take a number of different drugs. The same goes for hypertension and for most of the other chronic disorders. So you'll need to take a number of drugs. The problem with that is that when you reach the 6th drug, the 6th to 7th medicine, you're guaranteed to have a drug-drug interaction. So at that point, you're going to be treating the 8th and 9th drug. You'll be treating what will be the complications of the first 6, and then the cycle is difficult to break. I will talk to you at the end of why our current field is perhaps even worse than this, because our current field, most of the patients come to the center bringing in their supplements in the basketfuls. So supplement-to-supplement interactions have to be taken into account. Most of us are not knowledgeable enough to understand the sum total of this yet, but the experience will grow. And so simplification, strategic thinking, a plan that you can't address your entire body system at once in a single layer at one time, just taking the whole basket full of stuff and taking 50, 60, 70 medicines a day, supplements a day, is just not going to be an effective strategy. So one of my colleagues say at the university to me, when they talk to me, they say, well, what's the evidence that all this nonsense with acupuncture works? Show me the randomized control studies. And so I come back and say a lot of other things. Just not to the So we have really evidence-based medicine today in the United States. The evidence-based medicine is a good term, but it's largely deeply flawed, because the committees that govern our standards of care in the United States are actually governed by fairly small committees. The committees are all chairmen of departments, they are all funded by NIH, they're all funded by pharma, and they all have to do their research and fund their research in that way. And so there is a strong set of biases embedded within our current system. And I think the data in the New England Journal of Medicine about a year or so ago stated that 1 in 7 definitive studies for the standard of care in the United States has been contradicted in future studies. So every time, about 15% of times where the definitive standard of care is decided upon by a definitive study, it's contradicted later on.
That's wrong.
So show me that the concept of homeopathy works. How it's not possible, it's something that you cannot measure. So I said, well, okay, if you're going to go to the, let's take some of the definitive trials that have taken place in the United States. In this case, the largest study of women's health on estrogen use versus placebo. And was stopped very soon after the trial was begun because of the following risks that this was based on studies done a decade before showing the benefits. So this now is the contradictory study that has now become the new standard of care and guides our current care. So it's declined over the course around the world. But this study, the same population had been studied 10 years earlier, over a 10-year period. So it started 20 years earlier and stopped 10 years before this started, reaching the opposite conclusions. So understanding that trial design is fundamental to trial results. So understand that you can insert biases into any study if you want to show a result. And it can be done very, very cleverly. The concept is most of the men in the audience know, that total prostatectomy was overused in the United States and also used with the biggest variable of use of total prostatectomy was region in the United States as well as individual center. There were centers within a region that did no prostatectomies versus centers that had only done prostatectomies. So there was a tremendous set of biases built into the standard of care. And of course, we all know that this is gone, but this comes from the prior studies that showed the definitive nature of how important this was to the survival of prostate cancer. And then it was completely contradicted later on. So the concept that we're reading the New England Journal of Medicine as a biblical text, you understand that 1 in 7 times it'll be contradicted. And probably the biggest issue that you all are very familiar with is the use of statins. And as a cardiologist, having prescribed and been part of the research apparatus at Hopkins that made statin use the standard of care in the United States, we now understand that about 1 in 100 people get protected from an event. So it means 99 people are taking it without any particular profound benefit. Except we now know that if you extract lipids from certain organs, particularly the brain, you will have a higher prevalence of dementia and other related disorders. And I think that finding is going to be real. That finding is going to be real and partially explains the rise in so-called Alzheimer's or amyloid plaque derived disorders of the brain. And the reason I put this one on is because I have colleagues, even in global health circuits, but also in the United States, that want to create what's called a polypill. The polypill is something equivalent of us putting certain pharmaceuticals in the water supply. So polypill is a pill that you would give out to the general public. In this case, they wanted to do this in India, to give the Indian population a safe antihypertensive and anti-lipid lowering drug and something that would protect against the future development of diabetes in a single pill, sort of whether you needed it or not. And this was so frightening to me that we have to work hard at dispelling the benefits, particularly on the lipid side, which has been entrenched in the society for a long time. And then the concept of my colleagues who put their research careers into fast-track mode in genomics 25 years ago, and said that genomics will be the answer to all of our ailments and all of our illnesses and all of our issues and all of our problems. That hasn't borne out to be the case, and that's because of the level of complexity of our genome, and the level of complexity of an average chronic illness may involve 100 genes interacting with one another, and it's not going to be possible to deal with it on a simple level. But then when you think about it in terms of drug development, it will take us a few hundred years to replace our current pharmacopoeia with the new sets of medicines. So don't expect genomics to play a huge role outside of diagnostics over the next decade or two, because we won't be able to develop new molecular entities based on the genomic findings for at least 10, 15 years after their discovery. So we have to think about the whole system and not just a symptom-based set of medicine or an illness-based model. And whether or not we'll be treated by robots in the future, certainly men's databases are certainly going to be our reality. Genomics, all of this is yet to be seen, but I'm interested, as everyone else is here, in the present. So the question is not so much what the promise of medicine is going to be. The question is, how do you use the best that there is available right now and use it strategically for yourself and your family and the patients and the people that are asking you questions. And I think that this is accurately true. As trained as some of you have been trained here in acupuncture, I think we can take the pulse of a person in that particular way, or whether it's an analysis on the homeopathic side or naturopathic side, more than any single digitized technology that we have available today. And I think this is going to be the case despite genomics and proteomics companies starting left and right now for the foreseeable future. I'm going to skip over this just for some of you who can write down a note and look up the Hood group. This group based out of the Northwest, which is espousing the use of system biology in medicine. But if you look at it, that's a good thing. So they use predictive, personalized, preventive, and participatory, which are very good 4 Ps. But they look at it from a computational perspective and using mathematical tools. They don't use any evaluation on the patient. They're using patterning and chaos theory and so on, but they're not actually examining anyone or touching them or listening to them. So that's the level that we currently have in terms of where we are. So we're left with this level of complexity, and the question is what strategy we can use to address it. So going back to this, I thought I would take a few minutes and focus on the things that we know the best. As a cardiologist, I feel comfortable talking about certain cardiovascular disorders that everyone in cardiology knows are the least understood of the most understood field in current medicine. So I want to address it, and I want to point out. So before I get to there, I had someone tell me that this was way too complicated, and although it was real, it was too hard to digest. So I just pulled the first article I could find and came up with this, which is obviously a lot less complicated, but seemingly still imperceptible, because this is just the component of certain cascades on the inflammatory cascade side, which is, again, still an immense level of complexity on every cell. So we're talking about NRF2. There are 500 known chemokines and cytokines. These are the messengers that talk between the immune system and the neurokine system, the nervous system, and the endocrine system. These are all receptor-based, 500 of them. I can put them on a single chip. And I have developed with other colleagues the technology to do that. The question is what we would do with the data. We have no idea what we would do other than collecting massive amounts of information on people before and after they get treated by a holistic system-based approach. We wouldn't know what we were looking for, because if this is the orchestra, and the orchestra is composed of 500 individual players, I'm the composer. NRF2 is one of the potential band leaders for the violin section, for the string section. But one person blowing the buffoon over there, blowing the bassoon very loud, sets the whole thing off. And when you look at this, a colleague of mine pointed out to me that the new molecular entity that his company had just developed was right here. So he was really proud of that they had the receptor tagged and the molecule developed for it, but the interactions between the rest of the system are poorly understood, and that's why our adverse events rise and rise as we go into the general population. And that's why the pharmaceutical approach is fundamentally simplistic and flawed. These models are more useful as we go forward. There's a patient up here, which is at least good. And the concept of the future of regenerative medicine is clearly happening now. It's going to happen. It's going to dominate the medical environment over the next several decades. And it will be extremely cool and exciting because the regenerative medicine really is based under the understanding that if we can give ourselves our basic youthful cells, our own system will auto-regulate on its own. That you don't have to understand the complexity will take care of itself. But then we have artificial organs, we have all these novel things, and we have all of our basic elements of academic medicine, but what it doesn't take into account is really what it means to be the patient. and what it means to be the individual. And the next part of my talk, I want to address that, I think. I think that that's the next part of my talk. Although I have to thank Carmen for putting it together, but I haven't had a large amount of time to review it. So the concept of reestablishing homeostasis is the key, as many of you already know. But how do you think about it? So one very simplistic way to think about it